Today we're going to review lines of symmetry. And in case you forgot, a line of symmetry is just a line that the shape can be folded on top of itself. And it's just a line of reflection within the shape. So this square would have a line of symmetry straight up and down. Let's say that's halfway. It's not, but let's say it is halfway. Then that would say that this side would fold across that line directly onto this side. It would also have a line of symmetry this way. Exactly the same thing. This would fold over onto that and vice versa. And then also from corner to corner would be a line of symmetry because this side could fold over to that side. And then corner to corner the other way would be a line of symmetry. So this would have a total of 4 lines of symmetry. Now, on this one, it says how many lines of symmetry does this shape have? This is just the letter M. The only line of symmetry here is going to be directly down the center to where this side could fold over onto that side. You can't cut it in half this way because it just doesn't work. You can't diagonal either way. The only line of symmetry is directly down the middle, and this side could fold on over to that side. Now we get into this kind of problem. It says find the order of rotational symmetry in the shape. First, we got to talk about rotational symmetry and what it is. So for rotational symmetry, what that means is how many different ways you can turn this little star shape. You just rotate it around. How many ways I could rotate it around and it still looks just like this. So I could turn it on its side to where this side and that side's on the bottom, which I do, and it still looks like that star. I could also say, well, what if it's just this side and that side's on the bottom? Well, if you were to turn it around to where now this side's showing on the bottom as well, then it still just looks like that star. And the number of times you can do that and it still looks like the same shape is the order of rotational symmetry. This is the number for the order of rotational symmetry. So for the star, there's 5 different ways I can turn that and it would be the same. So I don't really have a way to animate that or anything on there, but I could put this on the bottom. So these 2 sides would be on the bottom, it'd look the same. These 2 sides on the bottom, it would look the same. I could turn it all the way around to where these 2 sides are on the bottom or where these 2 sides are on the bottom. As long as it's oriented in a way that you got 2 sides on the bottom and it's going to look like a star, then that would be an order of rotational symmetry. So let me go ahead and give you another example of that. I'll give you a rough sketch drawing of it. Let's say we had a triangle. Well, a triangle would have 3 the order of rotational symmetry would be 3, because I could turn it on this side, or that side, and as long as these angles are all the same, then the rotational symmetry of that would be 3, and you'd be able to turn it around that many times. And there's 3 different ways that you can orient the shape to where it still looks like the same triangle. And additionally, let's go ahead and do one more. Let's say we had a square. Now keep in mind, I'm talking about a square, not a rectangle. All 4 sides would be the same here in this crappy drawn square. You're probably already figuring out this would have a rotational symmetry in order of 4, because I can have it set on this side, this could be on the bottom, I could put this side on the bottom or that side on the bottom. Either way, any of these sides I could turn it on top of and it's still going to be the exact same looking shape. So that would have an order of symmetry of 4. I hope that kind of makes sense to you. Just remember, when your problems are asking what the order of rotational symmetry is, you're just figuring out how many different ways you can turn that shape to where it looks exactly the same as the original. That's all rotational symmetry is.